All right, all welcome to today's version of Developer Conversations. I'm your host, Alison Daley, the founder and CEO of Recruiting Innovation, and your host for the Tech Interview Transformation Series. Thank you all for being part of our program. I couldn't be happier than I am today with our guest, Samantha Kingston. Samantha is a local engineer in the Denver community. She and I have collaborated before on DevOps related coursework, and now she is here to share with us a little bit more of a bird's eye view into the world of DevOps engineering. She is a senior infrastructure security engineer at a company called Ibotta here in Denver. So she does more than just DevOps. There's also security elements and infrastructure, although all those things kind of live under DevOps. But we'll learn a little bit more about that today. Samantha, thanks for being here.
Thank you for having me, Alison. It's good to be here.
Yes. And for those of us, for our viewers, do you mind just giving us a quick little introduction to you, and also maybe giving us the highlight reel of how your career progressed into your role that you're in now with Ibotta?
Sure. So I've been working in the DevOps space for, it'll be 3 years in July. So it's not a super long time, but it is drinking from the fire hose. It's a very intense engineering experience, no matter which company I've done this at. I got into DevOps kind of by accident. I imagine a lot of people's careers could be described as a series of fortunate accidents.
Me too.
So I had started off as a full stack engineer at a smaller company in Madison, and then moved out here to Denver. And my first job in Denver was a front end engineer job. And I had just found my way into the DevOps role. I demonstrated an interest in security, automation, and just improving the engineering experience from a kind of user perspective, because the average engineer works with so many different tools now that if I can work in a capacity that makes the underlying systems they use just a little bit easier to interact with, then cool, I'm all for it. And that's really what a DevOps person does. Is another way of looking at it is fancy systems engineering. So a lot of what I do is writing code to automate the underlying systems that engineers use in order to actually run their code on a server, or stand up a database, or use event pipelines or observability pipelines.
Okay. I remember you mentioning that in our last conversation, that as a DevOps engineer, your customer is the engineers. And
Yes.
then for the engineers, the customers are the customers. That's such an interesting way to think about DevOps as a discipline.
In a microservices environment, we sometimes refer to them as customers.
Oh,
we're dealing with
okay.
a cluster of services, and the engineers are customers. So we do our best to hear them out on what their needs are, and then integrate their feedback into whatever automation we're actually working on at the time. Our goal is to make the engineering experience as seamless as possible, at least at the place where I'm working now. It's almost like engineering user experience.
I like that. Yeah, and then you kind of being the person that knows all about the tools so that they don't have to, almost.
Yes.
Awesome. Okay, well, I will have some follow-up questions on that element at the end of our convo, because I would love to unpack that a bit more. But first, it'd be great to just sort of listen and learn about maybe a typical workflow project that you've worked on. So for the folks that are in our Tech Interview Transformation Program, they are learning the software development lifecycle within the alignment framework structure. So, really teaching our recruiters about that 5-step software development lifecycle of research, design, build, test, and deploy. Mm-hmm. And I always think it's great to just sort of hear a live version of this conversation to really solidify the theory into a practice. So with that, the main part of our conversation will be around this project example. So for us, Samantha, would you share with us a project that you are most proud of, or that was particularly challenging within this the bigger DevOps role that you perform. What was the project? What was the goal of it, and how did you go about solving it?
So I think I'll actually stick with the one that I used in the training material, if that's okay. The
Please,
distributed
it's a
build
perfect
pipeline.
one. Yes.
I think that this one is particularly relevant because a lot of companies tap DevOps folks in order to actually move off of legacy systems and onto something a bit more flexible and sustainable. So this particular project speaks to that very well, I think. We have a legacy build pipeline that's like this big mono repo. And what I mean by mono repo is just a repository on GitHub that engineers all contribute stuff to. And at a certain point, it became really overgrown and just really wild. And there were so many services sharing this one repository that like logs for builds would no longer render. They would take, upwards of 20 minutes to actually build. And we just needed something that was going to be a bit easier to use and more decoupled. And so engineers could actually have their code and their configuration living in the same repository, and it could exist independently of everyone else. Because another downside of this particular approach to doing things is that if you break that or you introduce a breaking change into that environment, it breaks for everyone else too. So you have to, it can be a day ruiner. It's a real event. And you have to drop everything you're doing and fix it no matter how long it takes, because everyone else is now stuck too. So part of, I guess, getting into how we figured out what we needed, a lot of it was listening to engineering feedback and also being directly involved in efforts to fix this pipeline. Anytime it would break, it really was a drop everything kind of thing, like I said. And oftentimes engineers would come to my team and say, hey, this broke, but I'm not entirely sure why. So it affects not just that engineer, but also like the systems folks like myself who actually maintain those build pipelines. So we got a pretty good firsthand look into, or a firsthand perspective of what exactly was wrong with the system and why it just was not going to be sustainable long term.
So maybe can I just make sure that I'm understanding correctly? So
sure.
A build system. So if I'm a developer in your company and I'm writing code for, let's say, a feature fix or a new feature, right? So is the workflow for that developer would be, I write this code to build the feature and then I push it to that GitHub repository. And then if it goes well, it just goes live into the platform. Is that
That's
correct?
More or less correct.
Okay.
If it goes well, it means that your microservice living with, dozens of other microservices in this repository, like that build went well and it can go out and everyone else's code is like all copacetic as well. So, but if you introduce a breaking change, that's where everything kind of slows down for the day.
Okay. And then as it was in the mono structure, it was just like soup. It was all the ingredients were just in one big area. And then your goal was actually, let's separate that so that things are a little more isolated and therefore more manageable. Is that correct?
Yeah,
okay.
That is correct.
I want to make sure I understood. Yeah.
Yeah. And then engineers would only have to worry about their own microservices that they're writing instead of maintaining stability in that big, huge repository for everybody else. It was always kind of intimidating whenever anyone had to work in that repository. They were like, oh God, like clicking.
Everyone's going to see it. Okay. So then the goal was to then build mini repositories, one per person. For engineer.
It was to distribute the build pipeline to like a per repository basis. So a distributed model was what we wanted to move toward. It reduces blast radius for when you do make a mistake, because then it's just one service that's affected instead of all the others.
Excellent. Okay. So you're wanting to move toward the distributed build system model. And in the research phase at the beginning, you wanted just to hear from the engineers, like what are the problems and that sort of thing.
Yeah. And it just, it turned out to be just, largely inconvenience and unsustainability. It was hard to troubleshoot because everyone else's services were running in that same repository. So build logs wouldn't render anymore. So you couldn't really debug. You couldn't see the errors because the logs were just so long. So with this new distributed model, we found this tool called Atlantis that actually worked really well with our system. We're a Terraform shop, and Atlantis works with Terraform. So we were able to kind of tease out a design by at least reading their documentation, see how it runs, if we could actually host it in our environment, and how hard would it be to set up, and what would that look like. So we needed to put together a plan to figure out how to actually deploy this. So like where would the instance live? How could we make build status visible to engineers? And what Terraform do we need to include in order for it to actually work? So what were the constraints, and how could our environment best accommodate this solution? And where would we have to make up the difference? And this was, of course, after we decided that a distributed model was the way to go, and that this tool was clearly the best one for that job.
Okay. So once you decided that the distributed model was the way to go, then your job was to kind of figure out in the market what tools are there for that, and then what tools would work for us.
Yes.
That's how you landed on Atlantis.
Yes, that's correct.
Okay, great. And then what was the process from there? I'm sure that's just the beginning, right?
Absolutely. I mean, the documentation for this particular product made it very easy. It was like, oh, engineers can communicate or not communicate with, but they can at least see the build status of their Terraform in their repository. So there's just a very clear audit trail for entire teams. People can collaborate on infrastructure as code using this tool. And it takes out some of the guesswork of running something on your local environment, because you have to run it from your GitHub repository so everybody has the same version.
Okay.
It's a way to keep engineers safe and kind of save them from themselves, I guess. It standardizes code, and it introduces a heavier reliance on automated builds, not just for DevOps people, but for engineers as well.
Yeah, and the thing with automated builds is you want all of the data in the same order in order to automate the process. Is that right?
Yes, and you want it to run the same every time. So if you have your single source of truth for where you can actually build your infrastructure as code, then that means that every other engineer that interacts with it is also going to have they're going to have the same version. They're not going to have any uncommitted changes. They're going to be working with the exact same version of the code. And that's just a lot safer for everybody. We're not making any breaking changes without knowing it, and we're not introducing any unknowns into the environment. So it was really exciting to actually have this option available and as an open source tool.
There's probably some feeling of like, once you realize there's a solution for your problem, it's like, how would you ever not do it? Of course you're going to do it.
Absolutely.
Yeah.
Especially for something that's like us moving off of a legacy system that we know just is not going to be sustainable anymore. So this was just really exciting. So for the build phase of this, we had to, so it was a microservice that ran in our Kubernetes cluster, and we had to configure it in such a way that it could easily deploy to a multi-account cloud environment. And so there were some pieces that we had to do custom on our side in order to actually make that happen, and it involved digging into our legacy system to see how can we use like the better parts of this in order to build this new system. And we also included some little bits of automation for engineers who weren't necessarily as familiar with infrastructure as code. For example, we wrote what's called a yeoman generator. It's just like a node .js based tool for building skeleton files. And so an engineer could run this tool when they've got their repository all set up with Atlantis, and this tool would just build out the Terraform file structure for them. So they didn't have to do any guessing of what Atlantis was going to expect of them.
Awesome. So it's like a template, fill in this information, and then it'll work. Kind of.
Yeah, because you need a certain, yes. And with our tool, like, you needed a certain file structure that the tool was going to understand. And rather than just document it and having engineers make all these by hand, it seemed easier to just write some code to automate this process for them and just pave the way, so they don't have to worry about those little things and they can just get right to work.
Great. So were you, I'm sorry, go ahead.
Oh, no, go ahead.
I was gonna say, so were you the one then that created the human generator specific for this project?
Yeah, it was me and one other engineer.
Okay, great.
It was my first exposure to that particular generator type, and it was a lot of fun. It was really cool to then get feedback from engineers about what kind of prompts they would expect to see in this workflow and how they would know that they did it right.
Okay, so it sounds like it, even when you just making the decision toward Atlantis, there's still like other things. It's multiple parts of a project. The human generator being one, Atlantis being another. Were there more aspects within the build process that you had to create?
Not really, actually. The most that we had to do was communicate it out to engineers how it was actually going to work. And we did this through a beta phase. The beta phase was something that I felt really strongly about, because there's a common pitfall with DevOps teams is you can fall into this kind of ivory tower type thing where you just hand down standards and don't talk about them with people. But I really wanted our engineers to feel like they had a say in the process, because they are my clients.
Right.
And I want them to know that I'm doing the best I can to do right by them. And I want their feedback because I build for them.
Excellent. Okay. And so you built all the things, and then you did a beta. So that was your testing phase, was with a beta group.
Yeah. So okay. I put out some comms on Slack and via email, and I said, I'm really excited about this distributed build model for Terraform, and I am taking volunteers for whoever wants to try this. And if you participate, I'd like to sit down and chat with you after you've built your infrastructure and you've gone through the entire workflow to see what I can change, or what was hard for you and what you had the most success with. So I actually had a number of people sign up. We wrote step-by-step documentation. We did a couple of like live sessions where we did a demo and walked people through it and said, hey, this is way better than this other legacy solution that we have, and here's why. And we really want you to adopt this as the new standard. And this was actually the smoothest product rollout I've ever participated in, because there were no breaking changes in the beta. Nothing.
Congratulations.
Thank you. I know, it's such a rare experience. All of the feedback that we received was actionable and also was easy to work around with alternate solutions until we got those fixes out the door for people.
Okay. And so then once you were through the beta, then it went full deployment out to everybody?
Yeah, and how we did that was essentially communicating, we have this new tool, here's all the documentation, here's the recordings of the demos. This is our new standard. You will not deploy new services to this old solution anymore. So we were very clear about that. And what was cool was the organic communication around it too. Engineers were telling each other about this. So we actually didn't have any new services deployed to the old solution. Everybody was really excited about using the new one.
Well, that's probably extra feels good when you're building something and then everyone's excited to get what you built.
Yeah, it was fabulous.
That's awesome. And what would you say was sort of like the biggest challenge throughout that whole process for you?
I think, I don't know. All of my beta testers were really enthusiastic. They were super helpful with feedback. I think meeting my own standards in terms of how quickly are we moving on this? When can we get it out the door? So it was, I guess, self-imposed deadlines were probably my biggest challenge, but that's a growth point for me personally as an engineer.
Right. Yeah. We always, for me, my ambition far exceeds my available time.
Mhm. But
Managing that. Yeah.
yeah, absolutely. But all said, it really was a fantastic project. And it was one of the first times I think that the definition of DevOps really hit home for me was just, I build for engineers. They are my customers, and I really care about what they have to say about the things that I build for them. And I want to make their engineering experience a good one.
And how was the overall team's feedback once everything was live and the switch had been made? Were people happy?
Yeah, we took build times down from over 20 minutes to 2 minutes at the outside.
Wow.
Yeah,
Over time, that is huge.
yeah,
That's
absolutely.
amazing. Okay. And what would you say, like, if there was anything that you, reflecting back, is there anything that you would have done differently? Or were you quite happy with how everything rolled out?
I think I would have spent a little bit more time with non-service developers, like people who aren't doing feature engineering, but more maybe people on the big data side, to get an idea of what their needs are and actually accommodate them right out the gate instead of having proposed workarounds for them at first.
Are people that do big data stuff, they're a little bit outside the normal development flow for your
Yeah,
team?
their use cases tend to be just a little bit different. And it was, I think, the first time that I hadn't really the first time that I had to really take that into account, that we have all kinds of engineers working on all kinds of different things, and that the use case that we had built out for most of our engineers didn't work for everybody.
Got it. Yep. And that's one of those things you don't really know until, you're in it.
Yeah, absolutely. So it is something that's an important takeaway for me, and it is something that I carried forward into future projects.
Awesome. Okay. Well, that was a nice summary of, would you call it a monolith build system into a distributed build system? Is that how you would call
Yeah.
that project?
Yeah, at a high level, I think that's how I would call it.
Okay. Well, that's a nice bird's eye view into the world of DevOps. I'm curious, just to kind of open it up to other questions. So if anyone in the call has a question they'd like to ask Samantha, you can do it via the chat box at the bottom. Another few questions that we've been getting from our audience leading into this, just more as a DevOps engineer at a greater picture. One of the questions that comes up often is, when you are, receiving outreach messages, whether you're actively looking or not, obviously recruiters are going to be sending you messages and trying to recruit you. What are some things that in the past that has been effective in kind of getting you to respond to an outreach message? What kind of tips would you recommend to recruiters reaching out to DevOps candidates?
For me, if I get a recruiter message, I'm usually looking for, excuse me, some kind of indication of what the company's goal is with having a DevOps team. Because I am like the first to admit that DevOps is really buzzwordy.
Oh yeah. And you're like, what does it really mean for you, person?
Right. So it's like, what goals is the company working toward in their technology group that would require someone with my expertise? So what does the company want to accomplish? Is it more automation to reduce cost? Is it fewer engineers building things manually in the cloud? Like, what is it?
Okay. And that would be a question that we would want to ask when we're getting the new role from the hiring manager around
Yeah.
that.
Yeah.
another thing that we hear often is like there's a big difference between a startup going into DevOps or like large enterprise DevOps. Like how would you describe that for our audience? Is there a big difference? Or I guess there's also like the DevOps maturity. So there might be, this is like multiple layers. Like is DevOps maturity important to you as a candidate, and how would a recruiter kind of speak to that for you?
I've actually never been asked that before, if maturity is important to me. I think it was when I was earlier in my career, just because I needed something a basis for gaining knowledge. If I were going into a new role with not a lot of experience, if I were, say, like low mid, and I went to a startup that was just figuring out their own DevOps processes, I'd probably be a little bit lost.
Yeah.
So for me right now, I don't know that it matters as much as it used to, but I can only speak for myself in that regard. I think it would be good information to include, just to accommodate different levels of experience within that field.
Great. We had another follow-up question from your project example. Can you speak to a little bit about how Kubernetes have had an impact on DevOps? And really, can we step back step further and like explain what a Kubernetes is?
So Kubernetes is just a tool for container, or not container orchestration, that's like Docker, but it's just a framework for microservices. So it's just one way to run your microservices. Cloud environments some of them have their proprietary ones, like Amazon has Elastic Container Service, or ECS. That's one tool you can use. So Kubernetes is just one offering for however you want to run your microservices. I will say Kubernetes is quirky, and it has a lot of twists and turns in it, and there's a steep learning curve, at least for me. Some people take to it better than others. So it's trendy.
Yeah.
It's very trendy, and I think that it's difficult to get your arms around it at first. So I think it's important to mention it if you're reaching out to prospective candidates. Say, we're running on Kubernetes and within this cloud environment.
Okay. And then just to like paraphrase to make sure that I'm understanding a little bit. So prior to microservices, it was typical that companies would have one big platform, and that all the different things required to run, let's say their website and their digital product would be like in this one big platform, and you could maybe, deploy individually, but it would be all to the one big platform. And then now with microservices, so migrating a monolith, that'd be a monolith platform, into a microservices platform, those different functions are sort of like broken out into little islands. So like if one island went down, the whole platform doesn't go down. Is that the idea, that you're a little bit more nimble going into microservices? Did I phrase that correctly?
Yeah, that's
okay.
Correct. With like the advantage of microservices is that decoupling that you're talking about. Every piece of an application is an island. There are some drawbacks to it as well. You can end up with a lot of different languages in each of your microservices, and because of that easy interoperability, you could end up with services that eventually nobody understands because they were written in, I don't know, Scala or something, and all of the Scala people at your company got other jobs. That's just for example. But overall, it does allow an organization to be more nimble. If one part of the application goes down, typically your containers are configured in such a way that they will just spin up again.
Okay.
So whatever was wrong with your previous one, the container will just die and a new one will come up.
Okay, so the islands are containers. So they become, instead of islands of units, they're containers of services.
Yeah.
Okay. I'm like, I'm just making sure that I'm hearing you and I'm smiling, but I'm like, do I really want to, I'm really understanding?
Yeah. It's
great.
Several services running on a node, and the node can contain several containers. It's a whole like nesting doll of microservices.
Okay. And then, I saw obviously that you also have the security element in your title. Can you talk to us since we have a few more extra minutes, can you talk to us what are some of the things that you're doing around related to security in your role, and how does that exist for DevOps people, the security aspect in their work?
So it's something that we always try to be really mindful of. I personally got into it just out of an interest of my own. A lot of what we do, as I said before, is building out the underlying systems in an automated fashion, so engineers don't have to worry about those pieces. And the security aspect of it should be built into that. It's if we're automating the deployment of a specific piece of infrastructure in AWS, we should be including end-to-end encryption at rest, just any security feature that we can take advantage of while automating these things for engineers is something that I think we should take advantage of.
Yeah, make sure that it happens when it's happening rather than going backwards and trying to audit who had it and who didn't.
Right. Okay. So it's something that I try to include whenever possible, so engineers don't have to worry about it, or rather they don't have to worry about it as much.
Great. Okay, we got another question in that related to your career progression. I think this is, sometimes this is sort of what I see with recruiters, from like beginning recruiters to people that are more experienced in tech, and just realizing that, at the beginning, we just are really looking for keywords to match and titles to match, and, just trying to like apples equals apples. But then as you grow in technology and you understand that, a language is just a tool, and really you're hiring thought processes and skills and experience, and that the more experienced developers don't necessarily only want to code in one thing, or just because they have doesn't mean they will, and things bleed and you can grow. So can you talk to us about what that experience was like so you started in full stack, went into front end, and how did you move into DevOps from the front end / full stack side of things? Was that within the same company, or did you change jobs to become a DevOps person?
I changed jobs.
Okay.
So
Okay.
I was referred by a friend of mine who was looking for kind of a DevOps apprentice, as it were. And I just happened to interview well at this company and have the kind of problem-solving approach that they were looking for, which was, I think, my first lesson in it's not what you know, it's how you work.
Okay. And so then you were able to come into a place that they knew you didn't know a lot, and then they were able to grow you within that position itself.
That's correct. As a result, I'm a big believer in seeding talent, like wherever you can find it. It isn't a linear progression, I guess, in DevOps. Most people I know came from system administrator backgrounds, full stack. I think front end for myself was probably a little bit anomalous, but typically the engineers that I have worked with have come from different backgrounds than just administrative type engineering.
Kind of makes me think a little bit about how user experience is also like this big umbrella, and people can come at it from the development side, from the design side, from systems, information architecture. DevOps sounds like, because it is such a big umbrella and you have to know a lot, it makes sense that there's so many side doors into it.
And okay. I like having all of those different perspectives on my team.
Yep. What is one thing that you wish recruiters understood about the DevOps discipline? If there was one thing, or.
I do think it's just the organization's goal of having DevOps people in the first place. It's like, yes, automated processes are nice, having a build server and having certain guardrails around engineering processes, that's all nice, but what are you trying to grow? Or what are you trying to move toward?
Through the DevOps. Okay, that's a really good tip for folks that are working with directly the hiring team. what is your goal with your DevOps team, and how are you wanting to kind of improve the business through DevOps processes? Okay, great. Well, that's kind of rounding up our questions. So it sounded like we talked a little bit about outreach messages. We talked about some details around security, DevOps, containerization. Wonderful. Is there anything else that you think that you would like to share with our audience at this point?
Oh, I can't think of anything. Just thank you for listening.
Yes, excellent. Well, everything that we can add to our toolkit of understanding is useful and helpful. So Samantha, thank you for your time today and for sharing that story. I learned quite a lot just from this one example. Kubernetes and distributed build systems and human generators, and that's what we're finding is helpful with having the framework to follow. The alignment framework is that, I pull out the story. I might not know all of it, but at least I have it in a story form that I can transfer to my team pretty easily. So thanks for giving us one more example of what a workflow for a DevOps engineer looks like.
And thank you for having me, Alison. This was good.
My pleasure. Okay, everyone, this is Samantha Kingston. She's a senior infrastructure security engineer at Ibotta here in Denver. And I'm Alison Daley, your host of the Tech Interview Transformation with Recruiting Innovation. So stay tuned. We've got more developer conversations coming up, and we're glad to have you. Thanks, everyone.
Thank you.
Thank you.